Here we go with the number E. You already learned about I, which is an imaginary number. Now we actually have a number called E. What's going on? Well, E is actually a number. The number is approximately 2.718. And how that happens is a man by the name of Euler figured out this pattern where, you know, from the compound equation, if we have 1 plus 1 over n raised to the n, if we do 10, we're going to get 2.594. But then if we do 10 squared, which would be 100, that's going to bring you to here. And then as that keeps on increasing, once you get to like 10 to the 4th, 10 to the 5th, 10 to the 6th, 7th, 8th, 9th, 10 to the 10th, it's going to start repeating itself at approximately 2.718. So that's known as the Euler number, which is our natural base. Okay, so it has a value. So if you take your graphing calculator and type E squared in it, it's going to give you approximately 7.389. And all you have to do is type it in your calculator. So where is the E button? Well, if you look to the left of your number 4 and 7, you will see a log and an ln button. Well, it's second ln. Now this is, of course, if you're using the TI-83 or 84 calculator. So if you press second ln, this is going to pop up, E with a caret, and then you just type squared inside of parentheses, or in this case by itself. You don't really need the parentheses for this example, but you're going to get 7.389. So for this next example, if you type E to the, and then again, negative 0.5, and you're going to press enter, and it's going to give you approximately 0.607. And that's it. So E does have a value. So we can use E for problems, which we will in a very short few. Here we go. Simplifying, though. It can be treated like a variable with an exponent. So E to the 3rd times E to the 4th is E to the 3 plus 4, which is E to the 7th. We just got done working with simplifying variables. 10 over 5 is still 2, and 3 minus 2 is 1, so that could be simplified to 2E. For this one, we still treat it like exponents, so we're going to distribute. 3 squared is 9, and then negative 4x times 2 is e to the negative 8x. You know we're not allowed to have negative exponents, so this is just going to simplify to 9 over e to the 8x, and that's it. So you just treat these just like a variable, but they do have value. If you were to type these in the calculator, you would get a number. So the 4th root of 16 we know is 2, and 4 goes into 8x 2x times. So e to the 2x, and that's it. You're done. So it follows exponent rules, yet has value. Graphically, we can have growth and decay. Growth is when your rate is bigger than 0, aka a positive rate. If your rate is negative, that is decay. So very similar to exponential growth and exponential decay. If you type these in the calculator, since this has a positive rate of 0.75 or 75%, this graph will increase. In the second example, if you were to type this into your calculator, it has a negative 50% rate, which means it's decreasing by 50%. It's going to look like that. So you do not have to know how to graph any E equations by hand. All I did for those is type them in my graphing calculator, press graph, and I just sketched what they look like. Now here is where E is used the most. It's another type of interest that the banks can give you on your amount of money in the bank. So it's called continuously compounded interest. So the other day I mentioned, hey, you know what? It can be done like every second, every fraction of a second, and that's based on Euler's number, the natural base. So what the bank would do, it uses a totally separate equation. It's called A is equal to PE to the RT. So you don't even need to do that big fancy yearly, quarterly, monthly, weekly, daily type equation. If it's being compounded continuously, nonstop at every fraction of a second, you use PERT, PE to the RT. So if you invest $1,000 for 5 years at a 7% interest rate, it would look like this. 1,000 e to the 0.07 times t, the amount of years. So all you have to do is take your calculator, type 1,000 e, and the little caret will pop up, and inside of parentheses you just type 0.07 times 5, and what that's going to do is it's going to give you your amount of money after 5 years, which in this case A is equal to $1,419.07. Okay, I'd be shocked if you found a bank that gave you 7% this time, this day and age, but you know, it's fun to look at it and think, how awesome would that be if you can put some money in a bank, 5 years later have $419 more. That'd be pretty cool. But anyway, that is the number E. So you're going to apply this with exponential growth, exponential decay, but you're also going to be able to simplify it like exponents, and we'll be using it some more in other word problems as well. So that's it for now. This is Longo, and I'm out. See you, bye.